we do the composition, I told you for the domain, you have to look 2 places. You want to make sure you're paying attention here because this is several points trying to find the domain. You had to look at the original inside function as well as the final answer. Because I know the first thing I'm going to do, if I put in something that doesn't work right here, I won't be able to compose it. So when I look at this original inside function, if it's a fraction, what cannot happen? Okay, since my denominator is just x, that tells me x cannot be 0. Final answer was also a fraction, so that denominator cannot be 0. So if we add over the 6, divide, so x cannot be -6/5. I told you that in general, if you had more than one value that x couldn't be for your domain, you were allowed to just list them. So x cannot be a -6/5 or 0. Yes?
What was the other one right after
If there was only one value, you would say negative infinity to that number, union that number to infinity. Is that one okay? All right. Yes.
If it's a union, does it usually have brackets?
Parentheses. Because you don't want to equal that.
Oh, okay.
So if, for instance, you solved a domain and got just x cannot be 2, then in interval notation, that means it could be anything smaller than 2 or anything bigger than 2, but it can't equal 2 itself, so 2 gets parentheses. Other questions? So let's look at some more of the older stuff. So in talking about compositions, sometimes I had you work backwards. I want to know what f of x and g of x had to be originally. If, when I composed them, when I did f composed with g, I got this. So f composed with g, which one's the inside function? G. So if I'm looking down here, what's the inside? So g is the 3x minus 1. Okay, so if you think about when you compose, you replace your x with something. So when we're undoing it, think about if I take that out and just put an x back in its spot, what's my f? And you could always check these. If I compose them, do I get the 3x minus 1 to the 5th? And it does work out. When we were talking in section 2.8, we did compositions, but we also just did function operations like adding, subtracting, multiplying, dividing functions. So I did put one up here just to practice that. If f of x is 1 minus 2x squared, and g of x is x squared plus x minus 6, I want f minus g. So what do I do? So there's f minus, and there's g. So I need to distribute my negative. Combine like terms, so I have negative 2x squared and negative 1x squared, so negative 3x squared. Negative x. 1 plus 6 is 7. What's the domain of that? There's no fraction, there's no square root, so our domain is everything. Okay, so if I asked you to add or multiply or divide with those things, you could do that? Remember when we did the division, we didn't actually like do long division or anything. We just set them up in a fraction. Yeah.
How would you write the domain if it was a square root?
So if we had the square root of x minus 5, we know that under a square root you have to have a positive. So x minus 5 has to be greater than or equal to 0. So x has to be greater than or equal to 5. So it'd be bracket 5 comma infinity. Welcome. Any other questions with those function operations? Still with evaluating functions, what if for this function I asked you to find f of x plus h? So if I said like f of 3, what would you do? Put a 3 in for x. So when I say f of x plus h, you're putting in x plus h for the x. How do we square that? What? Okay. So this means x plus h times x plus h. So that's x squared plus xh, and plus xh is 2xh plus h squared. What do I need to distribute? No, we don't have any like terms, so that's our answer. So I don't have to only ask you to plug in a number. I have to give you some expression to plug in for our functions. Are those okay? I didn't put any up here. We sometimes did some like evaluating from graphs. Do you guys remember that at all? Like if I gave you this is f of x, and let's say that's g of x. If I asked you to find f times g of 2, what does that mean? So this is saying the x is 2 here. So when I go to my graph, when my x is 2, what's the y value of f? Times g of 2. So when my x is 2, what's the y value of g? And so we just get negative 2. So we did function operations from graphs sometimes as well. So that's okay? Alright, so that's kind of everything from 2.8. It was a lot. We did function operations, domains, compositions, all of that stuff. Then 3.1 was all the parabola stuff. So if I give you a quadratic, can you tell me, does this open up or down? Up. So does it have a maximum or a minimum? Minimum. How do you find the vertex? Opposite of b over 2a. We get negative 3 over negative 2 over 2 times 3. So I get negative 1/3. Then what do I have to do with that? Plug it in. Alright, probably not going to come out real nice because I just made this one up. So figure out what it works out to, guys. Maybe negative 6 1/3. Double check me. And how do you have to write that? When I ask for the axis of symmetry, I expect that to be written a certain way. The axis is a line. So you have to give me the equation of a line. So what is it? So just x equals the x value of your vertex. Intercepts. How do we find x and y intercepts? We did y-intercept a lot. I didn't always ask for x, but sometimes we did. And we can find it. Yep. Exactly. So to find my x-intercept, if my y is 0, what would I have to do with this? Factor it. So you guys do slip and slide. Right? So that would factor into x plus 5, x minus 3. Then what do we have to do with those? So we get 3x plus 5 and x minus 1. So what are the x-intercepts if you set each of those equal to 0? Negative 5/3 and positive 1. Okay. Y-intercepts. How do we find the y-intercept? When x is 0. So if I put in a 0 for all my x's, I get 0 plus 0 minus 5, so negative 5. Alright, so again, most of the time we only did the y-intercept, but you should be able to find either. Everybody's okay with that? And then we should graph it. I expect a minimum of 3 exact points on your graph. Obviously one of those has to be your vertex, which this one's not beautiful, but so we had negative 1/3, negative 16/3. Then my y-intercept was negative 5. So if you did your axis of symmetry, this is 1/3 away, so you could go 1/3 the other direction and get another point. Or we could use these x-intercepts that we found as points. A couple different options there. But either way, we should be able to then get our graph. Could you look at that graph and tell me the domain and range? What's our domain? Always. How do I want you to write it? Okay. And what's my range going to be? Yeah, it's actually negative 16/3 to 0, or to infinity, excuse me, because you have to start at your vertex. All right. Is this okay? All right, let's grade.